Good afternoon, class.
Good afternoon, Mrs. Hui.
Thank you. You can sit down. All right, then today we'll look at the last question we didn't complete in our previous lesson, and that was, I think, question 13. And I'm hoping that someone in the class will come and do it on the board. And then we'll look at an introduction on our two matrices. All right, the question was, VABCDE is a right pyramid, vertex V on a regular pentagonal base ABCDE. If it is 8 centimeters high and each side of the base is 5 centimeters, calculate 1, the length of the edge VA, the angle between the face VAB and the base, and the angle between the face VAB and the edge DV. Okay, is there anyone willing to do the question? Nobody? How come? I should have given it as an assignment question. Okay, the pyramid is on the base. The base of the pyramid is a pentagon. I'm not very good at drawing, but I'll just try. Okay, if the base is pentagon, then it should have how many triangles? 5? Okay, 1 in front, this is 2, 3, 4, and 5 on the side. All right, and it's V, A, B, C, D, and E. Okay, that will be the pyramid. It says the height of the pyramid is 8 centimeters, which means from the vertex B to the center of the pyramid, that will be 8 centimeters. All right, that's 8 centimeters. Each of the length of the pentagon is 5 centimeters. So that's 5, 5, 5, this is 5, and this is also 5 centimeters. Now the first question we are asked to do is to find the length of the edge VA. Okay, from what we know, we should know that VA is the same as VB, which is the same as VC, which is the same as VD, and they should be longer than 8 centimeters. Okay, note, is VA the same as, okay, or is VC will be the same as VA? My question is VC the same as the line that is drawn from V to the center of DC? No, because it is the perpendicular height of each of the base, each of the faces of the pyramid, each of the triangles. So it can't be 8 cent, or it can't be the same as VA or BC, VC. Okay, how can we find VA? Any suggestions? How can we find VA? Any ideas? Ponrele? Pastor Mike.
Find the length of the base to the center.
Is it this one? Okay, to do that, from the center I have to draw a line to the end of the, okay, to the vertex C or D. Okay, note that VD is exactly the same as VA, so we can find VD and it will be equal to that. Okay, we know that in a pentagon, this angle here is equal to 108 degrees. Okay, this triangle is an isosceles triangle. Okay, the triangle D, maybe I can just put a letter here. DMC is an isosceles triangle. We know that this is 108 degrees. We divide by 2 and we get 54 degrees. So this is 54. What I'm going to do is redraw the triangle on the side. So this is the triangle we are looking at. This angle is now 54 degrees. This one is 54 degrees as well. Okay, I want this side of the triangle, which happens to be the perpendicular height. This is 5, so one of them will be 2.5. So to find this, h over 2.5 is equal to 10 of 54 degrees. So h is equal to 2.5 times tangent of 54 degrees, which is equal to 2.1%, please. 3 point to 1 decimal place. Okay. So this is now 3.4. We need this with that, and we have to find, okay, this line. It's the blue marker. I'm going to redraw it, but okay, we need this line because if this is the perpendicular height, we can use that and then we can work out this. This is 2.5, so we can work out VD, which is the same as VA. Clear? Okay. Now, if this is now 3.4, and I'll now have to redraw another triangle, and this triangle is, this is 8 centimeters, this is a right angle, and this is now 3.4. Okay, I'm going to put T here, so this is VT. Okay, which we can very easily find by using Pythagoras theorem. Okay, just tell me the answer. The square root of 8 squared plus 3.4 squared. 8.7. I need 1% to tell me so it's clear. Okay, so this is now 8.7, which looks correct because it has to be greater than this 8 because it's the the hypotenuse of the triangle. Okay, now we are now going to find VD. This is now 8.7. Okay, I'm now redrawing this triangle. Okay, this is supposed to be, no, it's okay. This is D and this is T. Do we know what DT is? Yes, it is 2.5. It's half of 5. So dV is equal to the square root of 2.5 squared plus 8.7 squared, which is 9.1. Okay, so that is also equal to VA. Clear? Okay, next question. And again, that seems correct because dV here is actually the hypotenuse of the triangle DV and T. Okay, but because the right angle is here. Okay, next one. We have to find the angle between the face VAB and the base. Oh, do we need that line? And VAB, and the base ABCDE. Okay, we can actually calculate it on this side as well. It will be the same as the angle between the face VCD, right, and the base. Is it this one? Okay. Did we find it? No, not yet. Okay. I'll remove this. Okay, it's this one. That's T, V, and M. This is 8 centimeters. Okay, TM we already found to be 3.4 centimeters, right? That's the first one we calculated. So this is easy. 10 of the angle that we want is equal to 8 over 3.4. So theta is equal to 67 degrees to the nearest whole number. Okay. See, it's not that hard. Let us see. The angle between the face VAB and the HDV. Okay, the HDV between the face VAB. Where are we? VAB and the edge VD. Okay. Can I remove this first so we know which one we are looking at? Okay, you'll have to we'll have to work out where we are going to draw the lines. Remember how you have to draw the lines in the faces or the bases so that you can come up with the angles. Okay, it's between the face VAB and the edge VD. This is the edge VD and the face is VAB. Okay, what am I going to do to find out what the angle is? Any idea? Any suggestion? Can I just use the face VCD? Can I use the face VCD? Because the edge DC will be the same as the edge AB, but they want us to find the angle between the edge DC and the face VAB. So where are we going to draw the Huh? The HDV, which is this edge. It's going to, are we going to draw the line from D to A? Which one? We have to come up with a triangle. Can I remove this? Okay. It's the angle between the edge DC and the face VAB. The edge. I keep saying DC. I keep looking at the wrong one. It's the edge DV and the base VAB. The edge and the base or the face VAB. Okay, I need to draw a line. Where can I draw the line? Yes, Livingston. Nothing. Gabriel Chakumai? Come on, let's hurry up. We have to go on before we run out of time. Okay, Mr. Norombu.
Draw the line. Start from across the base. Start from between B and A to D.
Oh, sorry. This one, and then which angle? Can I put, what can I put here? Q? No, Q. So which angle? Name the angle we are trying to look for. Is that DVQ? Okay, VQ is the same as, huh? VQ is supposed to be a length. Huh? Yeah, VQ is, no, not 9.1, 8.7. That's VA. VD is 9.1. What about DQ? Can we actually draw a line from D through the middle to Q? Can we? From M to Q, it's 3.4. That's the same one we found from T to M. And from here to here, 4.3. What? Does it actually form a straight line? I hope so. So how are we going to find the angle then? If this is 9.1 and this is 8.7 and this is 7.7. Are we going to draw a perpendicular height from here? What's this angle? True? Okay, at 67 degrees, I have to find this, which is 23 because this is a right angle. Okay, that's 23 degrees. If I find this, then it will be, I'll use it with this one to find this angle and add it on to 23. Okay, using 8.7 and 67 degrees or 23 degrees to find this, sine of 67 degrees is equal to y over 8.7, which is it 8? Oh yeah. Is it exactly 8? I hope it's 8. Okay. Doesn't look correct to me. Sine theta is equal to 8 over 9.1. No, cos. Cos of theta is equal to adjacent over hypotenuse. Okay. So what's theta? 28.5? Okay, 2 decimal place 5. Therefore, the angle we are looking for is 23 plus 28.5, which is 51.5 degrees. Okay, good. You're all very smart. But one other thing, you have to defeat your fear. You are too scared to make mistakes. Everyone makes mistakes, so that's how you learn. Okay, we'll go on to matrices. Hopefully you read, except for the person whose book I got. Okay, the introduction to matrices. When a large amount of numerical data is or has to be used, it is often convenient to arrange the numbers in the form of a matrix. There is an example that's given in your textbook. That's the same example that I put on the screen there. Suppose that nurseryman, maybe his name is Taumaku, offers collections of fruit trees in 3 separate collections. He's a very good farmer. The table below shows the name of each collection and the number of each type tree included in it. Okay, he plants apples, pears, plums, and cherries. So collection, there are 3 sets of collection A, B, and C. In collection A, there are 6 apple trees, 2 pear trees, and so on. 1 plum tree and 1 cherry tree. You understand the table? Okay, so that's the collection. Because he is smart and he knows exactly that A, B, and C represent a collection and the numbers represent the number of each type of tree in each collection, or the numbers represent the number of trees in that particular collection. So he doesn't need to put a table, so he decides to draw or write it in the form of a matrix. Okay, after a time the headings and titles could be removed because those concerned are so smart with the packing of the collections that they would know what the various numbers meant. So the table could then look like this, which is no longer a table, this is now in matrix form. So the 6 represents 6 Apples. A collection, okay, the top one would represent collection A. 6 apples, 2 pears, 1 plum, 1 cherry, and so on. So that's collection A, collection B, and collection C. You are smart. Okay, the information has now been arranged in the form of a matrix, that is in the form of an array of numbers. So a matrix, a set of matrix, is just a form, or is an array of numbers. It's very interesting. A matrix is usually enclosed in curved brackets. Remember that this is the difference between, remember the type of brackets you used for sets? Right, it's different. That's why you had to use that specific one for sets, and you couldn't use this type for sets. The above matrix has 3 rows and 4 columns. 3 rows and 4 columns. Clear? 3 rows and 4 columns, yes. Don't mistake those two, because when you add and subtract and multiply, those are very important. Okay, in defining the order of a matrix, the number of rows is always stated first, and then the number of columns. Number of rows is always stated first, and then the number of columns. Okay, the matrix shown below is of order 2 by 5 because it has 2 rows and 5 columns. A matrix that has 3 rows and 4 columns will be called a 3 by 4 matrix. Clear? Okay, I'll just go over the types of matrix and then we'll finish, because this is just an introduction. The types of matrix, just like you have types of sets, the first one is called a row matrix. This is a matrix with only 1 row. So 3, 5 is a row matrix. All right, number 2, column matrix. This is a matrix having only 1 column. Note the difference. Row matrix is only 1 row and column matrix is 1 column. So 1, 6 is a column matrix. Null matrix. This is a matrix with all its elements 0. That's straightforward. Okay, number 4 is a square matrix. This is a matrix having the same number of rows and columns. It doesn't matter how many rows and how many columns it has. Okay, so long as it has the same number of columns and the same number of rows, it's called a square matrix. So this one has 2 rows and 2 columns. 5, diagonal matrix. This is a square matrix in which all the elements are 0 except the diagonal elements. So you've got 2, 0, 0, 3. This is called a diagonal matrix. So this is an example of a diagonal matrix. The last one, for this diagonal matrix, note that the diagonal in a matrix always runs from upper left to lower right. Clear? And the last type of matrix is a unit matrix or identity matrix. This is a diagonal matrix in which the diagonal elements equal 1. A unit matrix is usually denoted by the symbol that's supposed to be an I, that is supposed to be a little slanted like this. Okay, not straight. Okay, the one that I've got on the screen is straight, and it doesn't have that because of the font I used. Okay, it's supposed to be like that. So that would be the example of a unit matrix. Okay, when we come back next lesson, we will look at how to add and subtract and multiply matrices. Okay, the keyword to the pilot teacher is matrix number 2. Good afternoon, class. Thank you very much.
Thank you.